Okay, so our video from Monday's lesson is solving log equations, where the last week we did exponential equations. These are all equations involving logs. The first thing I want you to think about, if what makes one side of an equation equal to another? If everything on the left is equal to everything on the right. Well, if we're taking logs, if I'm taking log of 5x minus 1 and it equals log of x plus 7, that must mean that 5x minus 1 has to equal x plus 7 to make it true. So if you have one log on each side, the logs are already equal. What makes the insides equal to each other? So you're just going to turn log equations into regular equations and you solve it just like algebra. So we're going to get the x's on the same side by subtracting x from both sides. Add 1, and x equals 2. The one thing that you have to be careful of logs, you have to take the log of positive numbers. All right, the domain for logs has to be greater than 0. Domain x has to be greater than 0. Okay, not this part of it, but what you take the log of has to be part of it. Okay, so like if I plug back 2 back in, I get log base 3. 2 times 5 is 10 minus 1, which makes log base 3 of 9 on this side. And then when I plug x 2 back in for x on this side, 2 plus 7 is also 9. So that's what makes the left side equal the right, is when x is 2. Okay, so this one is different because there's only one log. So we're going to rewrite this. We can do this 2 ways. I'll show you this both ways. First, you can just rewrite exponentially. So I'm going to take the base of the log, raise it to the exponent, and it equals 3x plus 1. Okay, so that's one way we can do this. Let me show you the other way. Think in terms of inverses. If we want to get rid of log base 5, I'm going to raise both sides to the power 5 to the power, because 5 to the power of log base 5 cancels out, and I get 3x plus 1 equals 5 to the second power, which is 25. So either way gets you this. This is probably the more mathematical method to use. Then we just solve for x. Divide by 3. X equals 8. And if we think about this, that's a positive 8, not negative. My pen's goofy. If I plug 8 back in, I get 3 times 8 is 24, plus 1 is 25. And this should make sense that this equals 2, because 25 is 5 squared, and log base 5 of 5 squared equals 2, because the bases cancel. So x equals positive 8. All right, last few here. Anytime you have more than one log on a side, you first need to condense. So think of your log properties. When you add logs, you got to multiply the quantities together. So I'm going to condense into one log and take 5x times x minus 1, and that equals 2. Now, I'm left with one log on one side, so I got to cancel this log out. What is the base if there's not a base here? This is really important to remember. If you look on your calculator, on top of this button, the LOG button, it's 10 to a power. This base is always 10 unless there's another number there. Okay, so what we're going to do is raise both sides to 10, or if you prefer, you could do the 10 squared equals, but either way, we're going to cancel out the log. I'm going to go ahead and distribute and multiply these together. 5x squared minus 5x equals, remember this is 10 to the power of 2, 100. I'm going to move this out of the way. Okay, so what type of equation are we left with? This isn't a linear equation. If you've got an exponent of 2, this is a quadratic equation. So I always need to get quadratic equations equal to 0. So I'm going to subtract 100. Easiest way to solve quadratics, factor. Factor, 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 factor. I know that you heard me say that a million times, and it's because we use it all the time. And the first rule of factoring, GCF. 5 goes into everything. So divide out the GCF. Then we need factors of 20 that subtract to get 1. As soon as you have it, then we're going to solve for each of the x's that you see. I always just say split it apart. That's an x. X equals 5. X equals -4. Now, let's remember what I was saying earlier. First of all, these x's can be positive or negative. That's not quite so important. But we need to plug stuff back in. We can't take logs of negative numbers. So if I plug positive 5 in, 5 times 5 is 25, 5 times 1 is 4. That doesn't cause me any problems. So this is an okay answer. What happens though if I plug -4 in up here? I take log of -20. I can't do that. So this is what we call an extraneous solution. We can't use it. It's an answer that made this equation work, but it doesn't make the original equation work. So 5 is our only answer. All right, let's come back to number 4. All right, so if the base of the log is 10 with the letters log, what is the base when it's ln? Remember, this is base e. So what would cancel out ln is e both sides. E cancels out ln as long as there's nothing in between. So we get x equals e to the 4th. And that is all you need. You do not need to simplify that. That's the best answer possible. So when you see e or ln, you're going to use e. If you see e, you're going to use ln. These are inverses. Okay, so let's think about 5. 5 is just a little harder. We're going to solve it just like you normally would, where we get ln by itself first. So think of this as all connected, and we're going to just get it by itself. So subtract 2 from both sides. And if there's nothing in between, remember that's just multiply, right? So to get ln by itself, I now need to divide by 5. And how do I get rid of ln? So x is by itself. I use its inverse. I e both sides. And I cancel out ln, and I get x equals e to the 6th. And that's our lesson for today.